Hello, everyone, and welcome to the fourth and final installment of lesson 40 1, the addition rule. I know it's the last one, try not to get too sad. So, for this one, we are going to be doing number 15, which is on page 585, if you're following along in your book. Now, if you are looking in your book, you'll notice that this problem looks like one giant paragraph, and even me retyping it didn't really make it much nicer or neater. So, honestly, when it comes to a problem like this, the most important part is kind of organizing the information they're giving you. You're looking at this and you're thinking, whoa, this just looks so daunting. But once you break down the information, then you don't really need to look at the question anymore, and you can kind of just focus on the information and what your goal is. So that's my suggestion to you, is first just break it down. And that's kind of quite literally what they say in A. Right? They want you to use the given information with probability notation, and then they tell you, that they're going to go ahead and just call the lagged pipes L and the refuse recycling R. All right, but let's go ahead and read the whole thing and then we'll come back to that. So, if a household is selected at random from Elm Street, probability that the household has lagged pipes, I have no idea what that is, so don't ask, is 0.26. Household recycles its refuse is 0.63. And the probability that the house either has lagged pipes or recycles its refuse is 0.67. So these three pieces of information can be written with probability notation, and it kind of makes it a lot easier to see what's going on. So that's what we're going to do in part A here. And I'm going to go ahead and just color code this. Right, we have lagged pipes, we'll do in blue, the refuse in red. So, I'm going to go through and write this. So let's do the first one. The probability of lagged pipes. So that's just L. Right? The probability of L is 0.26. Okay. Same thing with the next one. Probability of recycling the refuse is R, which is 0.63. And then the last one is the probability of L or R, right? So I made it capital for you. I don't think it was capital in the question, right? This is an or problem. Remember, or is a union, so that looks like a U, and that is going to be 0.67. So all I've done at this point is just rewrote the information. If I wanted to, I don't even need to read up here anymore. I got it all, right? It's all shortened into three little pieces of probability notation. So I could even go one step further and copy this, right, and come down here, and now I can answer B and C without ever reading all that stuff going on up there. Now, also, if you're somebody who is a very visual learner, you can also make your own little Venn diagram if you wanted to. Right, you could sit here and maybe like visually, it makes more sense if you see it as a picture. So you can, make your little square. I'm going and making it like a little as nice and neat as possible, but whatever. And then you got your circle. That did not come out as a circle, so we'll try one more time. All right, and we have a second circle. It doesn't really matter if they look perfect or not. So we have L, we have R. It says the probability of L. So since it's the whole circle, you would draw a line to say that this is 0.26. And since it's all of R, draw a line 0.63. And then the union, you probably wouldn't put that in the diagram because it'd be weird, since it represents basically everything in the circle. So everything that, if I were to highlight that a little better, there's really no way of writing that other than just kind of listing it off to the side here. So that's going to be where we're at. So B, find the probability that a random select household has lagged pips and recycles its refuse. That should say pipes. That's a typo on my part. I apologize. We'll add a little E in there. All right, so we want to find the intersection. So in this case, you're going to want to use that addition rule. Do you really need to? Probably not. But in the end, if you didn't use the addition rule, you actually kind of would be using the addition rule. You just wouldn't know you're using it. Just the math would kind of turn out the same way. So again, when I learn a new formula or equation, I get comfortable writing it. If you don't know it, go back in your book or wherever. But I know that the union of the two letters, and my U's are awful. My handwriting is awful. I apologize. I need to get better. All right, so probability of L. The probability of L union R is the probability of L plus the probability of R. And again, we have to subtract out the intersection because it kind of happens twice. So, and again, it's not that it happens twice. When we have L, it's included in there. When it's an R, it's included in there. So including it twice is bad. We want to get rid of one of them. So that's why we subtract it out at the end. All right, so there we go. We have it. Now it's just a matter of getting the information I know and I wrote down already and just plugging it into this equation. All right, I know L was 0.26. I know R is 0.63. Those two get added, so I'll bring down that plus sign. There's a minus sign there. Equals, and now in this case, I know the union, which is on the left side of the equal sign. What I don't know is the intersection, which is over here on the right. So what I'm going to need to do is solve for, that probability of L intersect R. So I'm going to have to solve, and I guess we'll use green here. I'm going to have to solve for, oh, no, I lied. That's purple. This guy right here. All right, so what I would do, I mean, you can do this a couple different ways. Me, personally, I would most likely just add these two together. So let's go ahead and do that. I'm going to move this out of my way. First thing I would do is add those together. So this doesn't change. 0.67 equals 6789. 0.89 minus the intersection. All right, so all I did in the first step was I added the 0.26 plus 0.63 to get 0.89. And then what I need to do is I'm going to subtract out 0.89 because I want to get that intersection by itself. So the opposite of a positive 0.89 is subtracting 0.89. That turns to 0, so it kind of looks like it disappears. And on the left side, I forgot the minus. Don't do what I did. We're going to subtract those. Now, this needs to be done in order. So top minus bottom is going to give us a negative answer. So you need to be careful with that. All right, we're going to end up with a negative 0.22, okay, and that's going to be equal to, and right here we did not, we got to make sure we leave that minus sign here, right? We didn't take care of that minus at all. When we got rid of that 0.89, it left us with a negative probability. We don't want that negative probability, but luckily it's just a matter of kind of dividing by a -1 or multiplying by a -1, same thing, and that'll cancel out both negatives and give us what we want, which is the intersection is equal to 0.22. And if you wanted to check it, you could plug it back into that original equation, plug all the values back in and make sure they work. That's some way you can check it, but that is the correct answer. And that answers all of B and C, right? They wanted you to fill in the boxes. I actually didn't put that in there. I did it all fresh because I wanted you to see a fresh problem. And then what is the value? We circled that at the bottom at 0.22. Show your work, right? This is all your work right here. So that kind of answers the rest of this problem. Use these videos as a guide to help you with the exit ticket and check your understanding.